This is a complete tutorial for a API server that connects to a Shiny front end. This video just covers the backend system that this front end Shiny app is connecting to. Future videos will cover the front end development. We have Shiny input boxes and buttons that are connected to a FastAPI server. So the first step is to build our FastAPI server. I'm on the shell. I'm using a tool called UV, which is an alternative to pip. It's free. You can download it freely. The first step is to add the FastAPI package to my dependencies on Python. I'm going to use UV add, and then there's quotes, and I'm going to use FastAPI standard in square brackets. I'm first going to need to initialize the project. So I use UV init, and then I've added FastAPI, and I'll have FastAPI in the virtual environment of this project. This virtual environment is created automatically with UV. I'm going to activate the virtual environment with source and the name of the folder that the virtual environment is in, which is .venv. After that, I'm going to run Positron, which is a free editor. You can use any editor for this tutorial. There's nothing special about Positron for this section. By convention, I'm going to delete the main.py file so that it's pretty obvious that's a server application. I'm just going to call it API_main.py. This will hold the body of the Python code that we will build for our API server today. So this is a standard Python application, and we're going to use the standard Python import to import the FastAPI and also a package called Pydantic. And to add the Pydantic dependency, I'm going to use a terminal in the bottom of the Positron editor, UV add Pydantic, and now in line 1 of our new Python program from FastAPI, import FastAPI with this type of capitalization, and then from Pydantic, that package, we're going to import the base model. Pydantic is used for data validation. Since we'll be getting some information from the Shiny application, we want to make sure that the data is in the valid format, which we're looking for a string. And we're going to instantiate the FastAPI application with the Python variable app. And I have some problems here in my title. That should be a string. Title is the keyword, but let's go for it. I'll correct it later. We're going to use Pydantic here, and we'll create a new class, which is analyze request. It's going to extend the base model, and it's going to be looking for a type string. So now we can use this data type for analyze request in the rest of our program. First, let's set up a simple endpoint in FastAPI. We're going to create a new endpoint called health, which is common to check the health of your API server when you deploy it. So we use the decorator from FastAPI app, which we just instantiated, .get, and then it's the endpoint health. We'll create a standard Python function, def health, and we'll return a status of OK. At this point, you've completed your first API server. There's a syntax error line 4 that I'm going to correct. At this point, you could deploy it to numerous services, some of them free, and your API server would work. It just returns a health endpoint right now. We're going to test this thing locally on our development machine by running the command FastAPI. So in the bottom terminal, I've had my virtual Python environment activated. I'm now going to run FastAPI run, and it's the name of the file, which is API_main.py. And there's a bunch of information here about the FastAPI process. If you put -- reload after run, which I'll do later in the video, you'll be able to reload it when you edit the file. But for now, we'll open up a browser tab here and try it out. So I don't know how to use positron that well. I'm going to try to use it in a browser pane here, and I could use it here. There's a URL at the top portion here. I'm also going to attempt to use the browser tab. It gives me a little bit more space here. I like this horizontal or top and bottom. So I'm going to go localhost/health, which is the endpoint that we just created. And we're getting a status of OK, which is what we configured our FastAPI server for. So at this point, you do have a API server that is fully functional. FastAPI has a built-in kind of UI so that you can test out your API endpoints or provide documentation to your user base. The documentation is for other developers, maybe Shiny developers. So you create your FastAPI server first, and then you publish the endpoints. In this case, it's just one endpoint, which is called health. And then your user base can go to docs and see what endpoints that you created, and then incorporate that endpoint into their Shiny application, which we'll cover in a future video. They can also use this interface. So health is very simple, but you can execute the code itself. And use it for testing as well. It's nice that it's built in right into your application. So I'm going to continue on and create another endpoint here. And this is the one that does the business processing. So you're going to create some business logic. At some way, the data will get into your application. In this small demo, the data comes in through the post request as JSON to the endpoint analyze. So this API server is going to receive the data package that it needs for processing from the Shiny client, and then it's going to return the response. So the data that it receives has to be in the form analyze request, which we just specified earlier with Pydantic. This return statement is a standard Python dictionary where the key is a string and the value can either be a string or an integer. So if you recall that type text is a string. And we'll go back to the docs endpoint, which is built into FastAPI, to test the endpoints that we are building. I'm going to restart the FastAPI server using the -- reload after run here, so that when I update the Python code on FastAPI, I can refresh the browser and see the change. Now we have the analyze endpoint. And this is using a HTTP post request. So there's going to be a body. The difference between the get and the post, one of them is that the post can have a body or a payload. It's information that is sent to the server, and it will in the future be sent from the Shiny client. But for now, we're going to send it from this demo here, or this docs. So it's text : and then I'll just put a string there, and then we can execute it. Then we get the response right below that. It shows a curl example, and then we have the response. Let's go back to the Python code. Let's look at the def analyze, the function analyze. And the return, again, is a Python dictionary. So there's a key and a value separated by commas. The key is uppercase, and the value will be text.upper. So we're using the standard Python string operation to switch it into uppercase. So that .upper is built into Python. Same thing with length. len is a standard Python keyword. We're getting the length of the text that is sent to us from that JSON payload, which will eventually be getting from the Shiny application. And this is also standard Python. The text.split will split it on the space, and we're going to count the number of words in the list. So now if we go back to our docs where we have the analyze the post, and you can also do this testing within a standard web browser. I'm using a browser tab within Positron. Okay, let's go to the body. So we can edit the value here, and we'll just put it was the best of times. And that's the opening line from a famous book, A Tale of Two Cities by Dickens. We can see that it has the uppercase and it has the length of 24, word count of 6. We also have the curl request, which is automatically generated. I'm going to copy it into my clipboard. This is an optional step, but let's go back into the terminal. I'm going to paste the curl request into the terminal, use the curl that's built into the operating system. I'm on Mac right now. If you don't have curl, you can install it on Windows or Linux. And congratulations, you've built a full API server on the back end that we will adjust to communicate with Shiny. We're doing this so that in the future, we can get different types of data sources into FastAPI.